Hello everyone. Today I'm here to talk a little about the state of cloud applications and containers for RISC-V. It's kind of follow-up from my presentation from last year on the RISC-V Summit 2019 here in San Jose. My name is Carlos Eduardo. I'm a cloud architect at Red Hat, and you can check my social profile on Carlos at CarlosEDP. Just talking a little bit about me. I've been for a while working with multiple architectures and open source projects. I started a while ago on ARM architecture, wrote some posts about assembling clusters and Kubernetes on ARM architecture. I had a few posts hitting the first and second results on Google. Also, I started adding support for some container runtimes like Docker on RISC-V. Then I started a project to bring this all together and record all the information required for running and maintaining these projects. It's called the RISC-V Bring Up. There I bring together all information about all the projects, the pull requests and requirements to run these applications. Then I started a similar project for Open Power. That's another architecture that I follow. And I try to run Linux everywhere. So if you follow me on Twitter, you'll see that we've been running Linux on the Kendrite K210 small board. That's only like 8 megs of memory from the PS3 recently to have a new distribution. Also, I've been playing with FPGAs. I'm not too keen on them. Started learning the languages, the HDL languages like Verilog, and now I'm learning Chisel and Scala to see how things go. You can follow me on social networks at CarlosEDP on Twitter. You can read my posts on carlosedp.medium.com and also check this project and many others on GitHub/CarlosEDP. I'm a RISC-V ambassador, been appointed last year with great pleasure, and also a member of the Kubernetes community on GitHub. So, what are containers? Containers are a way to pack your software into a way of having the dependencies, your application, and requirements all together in one place. It's a standardized unit of software. It's like the idea of shipping a shipping container. You can have it on a train, on a cargo ship, on a truck. It's the same with your application. You don't need to worry on how you're gonna move this application from one container, one server to another, or from the development environment to the production environment, or the developer workstation. It's all the same. You pack it all together and you ship it to the multiple destinations you need. So similar to a virtual machine where you have the infrastructure, usually the server, you have a hypervisor, and you have your operating system with your application on top of it. On containers, you have a similar architecture, but it's more isolated. Your application don't require the full operating system and the full stack that a virtual machine needs. This is up the resource usage on the side of the server. Also, you can pack more applications in the same server because they are smaller and requires less resources. You don't have a kernel for each and an operating system for each of your applications in that server. So you can consolidate more and also distribute more, and also it starts a lot faster. You don't need to have a virtual machine boot on your server and causing load to your other applications. So we already have containers on RISC-V. It's a project I've been working for a while. I presented also last year. It's running Docker. Docker is a container runtime. It's the daemon that runs your containers on the Linux host. There is also another container runtime called Podman that's created by Red Hat. It also runs on RISC-V, so you can have your containers. They are all standard. You can run the same container with both daemons, Docker or Podman, or any other daemon that exists that might support RISC-V in the future. But here in this screenshot, I show that a RISC-V QEMU running. I built a container for an application called Echo. It builds the application, and then I run the container, and it prints, "Hello, I'm running Echo" inside a container. So you could, like, for example, deploy this container to a server environment or your development environment, that it would run exactly the same as long as it has Docker and it's Linux. And what's container orchestration? Once you have your applications inside containers, you need a way to deploy them into your environment, like your production environment or your Q&A environment. But it's very hard to manage all those containers with multiple applications. Sometimes you have one application with multiple containers. For example, a database and a front-end application that requires communication. You can have two containers, for example, talking to each other. But it's very hard to manage this situation, managing the servers individually. Then you need what's called an orchestration platform, and that's what Kubernetes does. Kubernetes is a way to have a complete orchestration platform composed of what we call the master nodes or the manager nodes that run some APIs and some daemons to manage the entire cluster, and the worker nodes. That's the nodes that have like some elements from the cluster, like the kubelet and the proxy that manages the communication between the nodes, but it's the node that runs your own application, as it's called a pod. As you can see, the bottom nodes here in the slide are the worker nodes. They run, in this case, a daemon as well. Kubernetes talks to this daemon to execute your container, and they run the pods. Inside the pods are the containers. And the API server and the master nodes manage all these applications in these containers. So if, for example, the worker node number one goes down, for example, the master nodes relocate your applications from one node to another dynamically. You don't need to do anything because it knows it's like a state machine. It knows you need to run, for example, the application X on your cluster. So if it's running on the worker node 1 and the worker node 1 goes down, it will move your application to the worker node 2, for example. And of course, it could have like some downtime. That's why you can have your applications as replicas with multiple containers running your application and distributing the load. So if one nodes go down, your application won't, it's still responding. It's the thing of beauty is that it's all dynamic. You don't need to do anything. You tell the cluster what you need, and the cluster will try to enforce your requirements with the resources it has. So we've already built Kubernetes on RISC-V. It already runs. I have a demo at the end of the presentation, and running Kubernetes on the Unleashed board from Sci5. And it's a quick screenshot running Kubernetes on the Unleashed board. So you see on top right, it's like a shell showing I run Debian on this board. It's an Unleashed board. On the bottom, we see that there are a lot of containers running. So it's an output from Kubernetes itself and running OpenFast. That's a function as a service application. It's a cloud native foundation application. That's also a member of Linux Foundation as the RISC-V Foundation. If you have no hardware to test this, like I have with the Unleashed board, there's no problem. You can have a QEMU virtual machine. I run inside the RISC-V project, Bring Up project. I have some QEMU machines for download. You can download and run on QEMU in your own computer. It could be a Mac, could be a Windows or a Linux. But also, I have wrote a guide on how you can build your own stack for a virtual machine. You can assemble together the bootloader, the kernel with all the configurations required, and also the root file system. It could be Debian, it could be Ubuntu, also Fedora. They all are already building packages for RISC-V. And also, I wrote a guide for the Unleashed board. It's a little bit bigger because it has more steps on it, since it has the first stage bootloader, OpenSBI, U-boot, but you can have in the end a complete file system and kernel and all the stack required for RISC-V. It's all in the Bring Up project. Uh, I'm talking a little bit about some application, some developing languages that's core to the cloud world. The first one of them is Golang. Golang, a lot of the applications nowadays are built on Golang, like Kubernetes and Docker. So they are like the backbone of the cloud world. Last year, Golang was still not upstream for Kubernetes for RISC-V, but I'm glad to say that it's already in 1.15. It's already upstream, so you can build Golang and run in your RISC-V board. But also, since Golang can cross-build applications, you can get Golang on your Mac or your PC and build binaries for RISC-V. It passes all tests, but still has no official build, since the Golang team is still assembling and checking the stability. Since it's a very new architecture, they still don't provide builds for that. But on RISC-V project that I have, on the Bring Up project, I have builds for RISC-V. I'll talk a little bit about CGO. CGO is a way to run C modules on Golang. It was still pending. We had no development last year, but now it's already merged. It's already in tree for the Golang master tree, and it will be out on 1.16. So a lot of applications that require CGO are able to be built already using Golang from master, or will be able to build on next year's Go 1.16 scheduled for January or February. We also have already a CI builder, so all PRs and all patches are already tested on RISC-V. It's a little bit small, but you can see on the red box that I draw around on the right side of the screen. It's already building and testing all the applications. And also we have a lot of what they call like PRs, pull requests for Golang. A lot of improvements, and a lot of them are already merged, like the CGO and improvements for some code generation. So RISC-V on Golang is progressing a lot. It's pretty quick, and it's great to have Golang fully working on RISC-V. It allows a lot of applications. Another great improvement that we saw, another great language we saw recently is Node.js. On the RISC-V global forum in September, we had a presentation from the guys that run the project. It's currently run by Huawei guys, and it's already very up to date. It's running Node.js 14.8, passes most tests, and a lot of modules work. This is still not upstream. They are working on it, and no official builds. Actually, there is already an official build recently. I saw this last week. You can check the repository v8 RISC-V /node on GitHub, and I also built a container image you can run in your own QEMU or Unleashed board using Docker or Podman. So if you want to play with Node.js on RISC-V, you can get the image at Docker Hub. That's Carlos EDP /Node.js. Here you can see a demo, a screenshot of a demo of a small application that I've built using Node.js and a nice and very well-known framework called Express.js, running like a hello world. Hello, I'm running inside a container in Linux RISC-V. So a lot of improvement. It's a huge project from Huawei guys, because Node.js depends on the JavaScript virtual machine called V8, and it's very low level. So it's an amazing work, and you can see the presentation video from RISC-V for Global Forum on YouTube from September. I'll leave a link in the end. I have a lot of container images already built for RISC-V, so you can see check on Docker Hub. This came from the project, from the Bring Up project. So I already have OpenFast, that's the function as a service platform, Prometheus, a monitoring platform, Traffic, the ingress for receiving traffic, Kubernetes itself, and many other images like the Echo demo, core DNS. So a lot of the images are already multi-architecture, so they run on ARM, on AMD, on RISC-V, on PowerPC. So the idea is having, like I said, one image to be able to run anywhere. I need to update the images for Kubernetes. It's still 1.16. I will probably planning to build them for 1.19 that's been recently released, and mainly with no patches required. So for this past years, last year and this year, I've been patching more than 20 projects, more than 40 pull requests sent, more than 6 CNCF projects that's being addressed on this, and most of them are upstream. So you don't need patches or apply PRs or fix some stuff like this. You just need to build them. We had some stuff pending last year. This is the list from RISC-V Summit last year. And happily, I can report that a lot of them have been already supported. So Golang is already upstream. SecComp, that's security component from the kernel, is already upstream. libseccomp, Kubernetes is already upstream, the support for that. We still have to provide official support, but I'm working on a PR to report it. Golang Seago, it's already merged. It will be available next version. RunC, that's the runtime, already can be built with the Seago from main branch. SQLite, but we still lack support from the main Linux distributions. We still need main distributions to support officially RISC-V, so we can also build the official images, the official Docker images for those distributions. And also, after these images are ready, I can start to be meeting CIs to build the applications officially on RISC-V. I'm gonna show a little demo of RISC-V running Kubernetes. Here I SSH into my Unleashed board. It shows them running Debian on RISC-V. It's running kernel 5.3, but there's already newer kernels that works. I have a lot of containers running using Docker. Docker is the runtime that's running these containers. There's a lot of them and lots of IDs, consuming around 1.5 gigs of memory. Not a lot of CPU, around 20-25%. Here showing Docker information. It's running on Debian Linux. It identifies correctly the CPUs on Unleashed board and memory for CPUs, 7.78 gigs of memory. Here, the Kubernetes command that shows the node, the Unleashed node that I run, and what this node runs and its information. So it also identifies that's running on RISC-V and has all the labels required for Kubernetes to identify this kind of node. So you can have, for example, multi-architecture clusters with like RISC-V and AMD nodes. Here are the pods, that's the containers that's running, the main containers from the core. And OpenFast, that's the function as a service, as an example application running here. This shows the inputs, the doors for the cluster, the URLs that you can access the applications. For example, Prometheus, that's this application that is the monitoring layer for the OpenFast application. It collects information. It's also written in Go and built for RISC-V, already being able to be built with no patches. Monitoring all metrics from these what they call endpoints and targets. So I can query, for example, so if the applications are up, it shows as 1 in the value, both instances, the gateway, and the node itself. Now we can access the gateway for the application for OpenFast. It shows we have one function deployed. It's called Figlet. It's ready, has one replica, and we can call it using this argument, hello RISC-V Summit 2019, and it generates a nice like MOTD banner for us. It's a simple application, but it's deployed as a container in the function. So you can see that the invocation count has been updated. It tracks all this information. Also, you can access it through the command line, show what functions are deployed into our cluster. It's interacting directly into the cluster, the Kubernetes cluster, showing all the elements in the cluster. So we have a service. We can deploy now a little application called Echo. Here we create a deployment using this container called Echo. I'm going to split the screen to be easier to see. We have no resources running yet. Now I'm going to deploy the image, Echo RISC-V. It's showing container creating. So we have the application being deployed into the Kubernetes cluster. Now I'm going to expose the application, a way for it to be available to be accessed. It shows that it's exposed. You can see the container is still creating. And now we are going to create what's called the ingress. That's a way for the application to be exposed outside the cluster through an URL. You can see it's like echo.my internal IP. If we open the browser, we can see it's a hello world running on Linux RISC-V inside a container. So it's a complete application. And now you can see all elements pertaining of this application. The deployment itself, the service, the name, the replicas that has, it's all complete. That's it that I was meant to talk to you all. If you have some doubts, contact me on Twitter, CarlosEDP, read my posts, and follow all the updates on GitHub and my images on Docker Hub. Thank you very much.